One of the fundamental issues in physics is the definition of force and field. A force is an action that has direction and magnitude. Here is an example of a force. That is the engine, a truck, and the force have to be applied through the drive shaft. That's the drive shaft. Comes from the transmission. You look at here, it comes from the transmission. And it applies to the differential of the tractor, and the tractor have to move the wheels. These are the drive wheels. The point of action of the force is right here at the kingpin. My finger right in the middle between these two jaws. This is the force that has a direction of the truck that pulls, and a point of action that is the kingpin of the trailer, and the magnitude that depends on the engine, how big the engine is. That is a force. A field is different. A field is like the field of gravity. Why gravity is different from force is because gravity affects every point in the body. So every point in the body has, in the field of gravity, will have a force added. The only difference between the force of gravity and the force that is produced by man actions is the fact that to produce a force you have to have fuel, you have to have engine. You cannot produce force indefinitely. You can only produce force for as long as you have fuel and the engine is running. So we got fuel. You run the engine produces torque. The torque can generate force. Then you can move the container. You can move the tractor. When you run out of fuel, you run out of force. So the force stops. That's the difference between gravity, which is a field, and force, which is a single action. So the force ends when your action that you are using, when you use to generate force, ends. In the case of gravity, the gravity doesn't end. The gravity is a very amazing fact of nature. We don't know how gravity is created. So the other aspect of gravity is why objects are attached to the earth, why the atmosphere is attached to the earth, and why you are not flying away horizontally, assuming that if the gravity is a vertical force that's pulling everything down, that is not going to explain why the objects are not flying horizontally. Because the gravity is a field, not a force. It generates force at each point in the body, which means every particle in the atmosphere that we even don't see it. Look at you, we don't see the air. But that air is attracted to the gravity by a field that generates force everywhere in every particle. So the reason that we are attached to the earth, not only because of the force of gravity that's pulling you down, is because of the field of gravity that is generating force at each molecule of the body. So you have two actions on every molecule, particle of the body, every body. That is the The field that creates force at each point of this body that pulls it down, and the centrifugal force, because of the earth is spinning around its axis every 24 hours, the surface of the earth rotates about 25,000 miles as the equator. Here in Utah, you can say the speed of the surface of the earth about 700 miles per hour. That's very close to the speed of sound. So why we don't feel it is because you have force at every particle in your body, not only as a center of mass. Every particle of the body has two forces. A force generated by the field of gravity that pulls you down, and a force generated by the rotation of the earth that expels you away. That is the centrifugal force. To summarize the difference between force and the field, force is short-lived action depending on the method you use to generate power, burn energy. Burning diesel, you can generate locomotive force. The locomotive force, you use it to pull a tractor and a trailer. It will end when the fuel ends, and it has a direction, magnitude, and is a point of action. This is a force. The field is not a force. The field is action in the space that affect anything, any particle in that space. At that particle, it will generate force directed towards the center of the earth. And the field of gravity is not limited in time. It is there forever. That's the most interesting thing. Remember, the gravity and the electricity are very universal, fundamental forces of nature. We don't know why the electrons are negatively charged. We don't know why the protons are positively charged. We don't know why they expel each other. They do that forever. You never hear about an electron losing power, that the electron cannot attract the proton because it's out of power. We don't even have a clue why. We don't have a clue why the earth doesn't run out of gravity.